Hey everyone, and welcome to the tutorial series for the Procedural City Generator. Today we'll be taking a look at city optimization. We're going to cover a wide range of topics, but they're going to be mostly focused on these three key areas here. First, asset preparation. When we're adding our own custom assets to PCG, what are the things that we can do to make sure that we get the most performance out of our assets? We're going to be looking at how we can adjust the max draw distance around the player. That's one really easy way to control performance and dial it in. And finally, I'm going to briefly mention how to use hierarchical LODs, which is going to help us significantly. So first thing, before we actually dive into all these things, I'm going to go ahead and jump into Unreal. And I've created here a little city, and you can see that is very, very long and not as wide. And I did that on purpose so we can test performance. So right now, if I am right here at the top view, which means that I'm almost rendering everything, and I click on show FPS, you'll see that we're looking at a very, very low, about 8 to 9 frames per second. There are a lot of objects here. If I go down a little bit more, you can see that the FPS increases a little bit more, and now to about 25 FPS. And that's because obviously with this view, Unreal is not rendering everything because of occlusion culling. If I press G on my keyboard and go into game mode, notice that the FPS increases significantly to about 47 to 48 FPS. And that is again because certain additional things are coming into play, like distance culling in addition to just occlusion culling. So I wanted to kind of show you guys this, and we're going to try to increase the frame rate here by looking at several different things. So the very first thing we should do is we should unlock the FPS to get a much better counter of what we're actually getting. And by default, I think the editor locks the FPS to 120, and if you go ahead and look down to the floor, meaning we're rendering pretty much nothing, you can see that the editor is still at 120 and is basically capped. There's actually a very easy command that you can do to unlock this, and you can press tilde and do T dot max, and you can see at the top FPS right there, and then you can put in a number, and I'm going to put something like 400. It doesn't really matter, my computer's not that powerful, but you can see immediately my FPS goes to like 170, 180, something like that. That means that at least right now, without rendering almost anything, my computer is there. If I look at the distance, 170 or so. And then when I go back and look at the city, then we can see that it goes back to like 40, 45. All right, so with that said, we're going to be doing tests in Pi just for convenience. If you really want to gauge performance, you don't want to hit play here. You want to go to new editor window or standalone game, because just looking inside the editor, there's additional things that are happening that are going to hinder that performance. But again, we're going to stay in Pi, and as long as we do the same thing consistently, I think we're going to get an idea of how we can increase our frame rate. So if I go back to the slide, the very first thing we're going to look at is reducing the number of meshes. Starting in 422, which is the baseline version for PCG, Unreal is automatically instancing similar static meshes. This is one of the reasons why, if I click on a building, any building here, I specifically make sure that the buildings are a single static mesh. So if I click here on this building and I open it, you can see that we have just one static mesh represents the entire building, including all of the walls, etc. The reason for that is, well, it helps us reduce draw calls, and it helps us auto instance when we are at game time. So right now, notice that we're looking at about 40 to 45 frames per second. If I click play here, let's see what happens with the frame rate. And it's going to take a little bit to go into play mode, but just notice what happens with our frames here. Just give it a second. Notice that it's now at about 80. And if I actually go to full screen, you can see a little bit better. It's between, yeah, it's about 85, 86 frames per second. So almost double the frame rate. And that's because Unreal is auto-instancing all of the static meshes in the scene that can be instanced. So that's one benefit of using an older version of Unreal Engine. A more recent version is if you have the same mesh over and over, you don't have to manually convert into hierarchical instance static meshes, or HISMs. The renderer does that automatically at runtime. So that's one thing that we need to keep in mind. At runtime, we're getting much better performance than at editor time. I'm going to go ahead and put stat unit, and that's going to help us give us a little bit more information on the right hand side. And I'm going to go ahead and exit. You can see that now we're back to our 45. So that's one thing is to keep in mind is try to reduce the number of meshes. If you have a modular building, what you can do is you can combine the meshes inside Unreal to try to reduce the amount of draw calls as well. All right, so that's one thing. Another thing that we want to look at is using aggressive levels of detail, aggressive LODs. Again, this is all general information, but I'm getting a lot of questions about performance, so I wanted to go ahead and cover it. So what is a level of detail? And I'm going to give you the super high level explanation. You should go to the documentation and actually take a look. But the idea here is that Unreal can automatically generate different versions of the same mesh in different levels of detail. Hence the name levels of detail. So if I open this mesh in the mesh editor here, you can see that if I get really close, right here says LOD 0. This is the full mesh, and this building has 50,000 triangles. And as I start going back, notice that now, even at this distance, right now the LOD is now at 1, and the triangles are cut down in half, between 50 to 25,000. And notice that you can barely notice the difference. So as I keep going farther and farther, now that LOD is 2, now this building is only 15,000 triangles. And as I keep going down, now at this distance, which is still pretty big, only 7,600 triangles, right? And I keep going down and down and down. And eventually, when I'm about this distance, something that was 50,000 is now at about 10% with only 5,000 triangles. That is me being very, very aggressive with LODs. And I even have a custom setting called PCG building that I've created in the ini files that automatically creates 5 levels of detail and is very, very aggressive. So if I wanted to come here to the build set, well, maybe we shouldn't look at all of the settings here, but you can actually go here and check, for example, LOD 0. Actually, let's look at LOD 1. You can see that LOD 1, what I'm doing is I'm saying, if the model is at 90% screen time, I want the percent triangles to be 50%. That is how aggressive I'm being at cutting the amount of triangles to try to reduce the load on the system. That is extremely aggressive. So you're only going to be at LOD 0 when you're 100% of the screen or more, meaning that the player is literally inside the building or right next to the building. If the player is even a little bit farther, then the building will automatically be cut in half, right? And that's basically what I'm doing. And there's a really nice view mode that you can use. If you click on lit, you can look at, let's see, level of detail coloration and click on mesh LODs. This is a nice little way of seeing how LODs are working. So right now, white is LOD 0. And as soon as I go back a little bit, you can see that we go to red, that's 1, and then green is 2, and then blue is 3, etc. So as I'm walking around my city, notice that very few buildings are actually white. So that is one way that I'm keeping the LODs as low as possible, in other words, and keeping performance high. So that is one thing that you definitely want to do when you add your own custom assets and your own custom buildings. Make sure that you come in here and you create aggressive LODs. You can use my custom setting if you want, and look at how I calculated the distances, and you can use it as a model, or just use whatever you think gets you the best results. But again, this is perhaps one of the most important things you can do to make sure that your city is performant. All right, let's go back. Go back to the slide here. So that's definitely one thing. Another thing is reducing draw calls. And two things are going to affect the draw calls: the number of materials per mesh and the number of meshes themselves. So right now, if I go back to Unreal and I open, I'm gonna cancel that, and I open my little apartment here and I go to material slots, you can see that we have 8 different materials. That means that a single building on the scene will be 8 draw calls. Every single material is going to be a separate draw call, which means that you should try to reduce the amount of material slots in your meshes. The less material slots you have, the better it will be. So if you can have your custom assets, your custom buildings have only 3 materials, and you can reduce it from 6 to 3, for example, that is going to make a huge difference as far as draw calls. The reason I kept them like this as default is because in PCG I have a system to change and randomize materials. So it was just easier to do that. But if you don't need that feature, you can click on Bake Out Materials, and Unreal will try to generate an atlas and will have only 1 material slot for your entire mesh. All right, so you might want to try out. There are other marketplace assets like Bake Mesh, I believe it's called, where it's a lot more advanced than this, where you can bake down and actually specify which material IDs to combine and which ones to leave. So this is one of the areas, for example, that I have not optimized my assets in PCG, and I could do a much better job. But again, I opted to leave it like this for flexibility because you guys can come in and just change the materials, and then the meshes are a lot more reusable that way. All right. And another one is just draw calls, is the amount of buildings and assets that you have. And one handy command that you can use, I even put it here on the slide, is stat RHI. So if I come here and I do stat RHI, you can see here, right here, I'm gonna make this a little bit bigger. You can see here, draw primitive calls is the number of draw calls that we're having. It's 14,000 draw calls. That is a significant amount of draw calls, which is why we're getting, you know, the 40-some frames per second. If I go down to the floor, notice that now I'm getting only 227 draw calls, which means that now we're at 140 frames per second. And obviously the draw calls means how many objects are being rendered in the scene in the current view. So of course, as I move my view here, you can see the number completely change. And right here, I'm on the edge of this city on purpose because this is the worst possible scenario. A very long city with a lot of very dense buildings, and I'm exactly at the edge of the city. If I were to go all the way to the middle of the city, right, somewhere here, for example, I should be getting much better. You can see that the frame rate, whoops, it's a little bit better. It's about 68, 69 versus the 40-some. So again, it really depends on the density. I'm gonna go back to here, of where you are. So just keep that in mind. This is one way of actually seeing how many draw calls you're having. And then from here, you can start reducing the number of materials and the number of meshes that are going to be rendered to get this number down. All right. Let's see what else. The other one is managing texture streaming, the number of textures and the size of the textures. You can use the command stat streaming. So I'll just enable it real quick. And again, I'm not going to go through these settings very much, but this basically tells you how much memory the textures are actually taking versus the texture pool, the amount of memory that is dedicated to the textures. If you have very, very high resolution textures, you're going to start seeing a little message that says here that you're over the texture streaming pool. You're going to start seeing hitches as you move around. If you like turn quickly, you'll see some hitches. If this is an issue that you're encountering, then this is because you're having way too much memory consumed by your textures. In this case, we've actually optimized the textures fairly well. So you're seeing here that we're doing pretty decently. Another handy thing that I like to show, I'm gonna remove this, is to use the Asset Audit just to take a look at how all of your textures and just general assets are doing in your project. So I'm gonna go look down here. If I click on the root folder here, Procedural City, then I right click and I click on Audit Assets, I'm going to get this nice window here that basically shows everything. And I'm going to reset the filters. You're going to get all of the assets in your project. So if we wanted to look at textures, we can click on Filters and go down to Texture. And then you can sort by whatever. I'm going to sort by disk size. So this sand normal map is taking 11 megabytes or megabits on my disk, and it has 2048 by 2040. So this is a 2K texture, and you can see all of the textures here, 2K textures. Then you have a 512 by 2K, and then 1024 by 1024. Two things to keep in mind here. All of your textures should be power of 2. That's basically the most important thing. So 128, 512, 1024, 248, and if you want to go 4K, that's fine. But just keep it as a power of 2. That way Unreal can create bitmaps and actually stream the texture properly. And second, the actual size of the texture is also into consideration. There are some textures here, for example, this road texture. If I'm going to browse to my asset here, if I actually open it here, you can see that the texture is imported as a 2K texture for the roads, but is displayed at only 1K resolution. And I did that because I noticed that the quality was almost not noticeable, and it increased performance significantly. And the reason I did that is, again, you have a lot of roads in your city, and you can force a texture to render at a lower quality by using the LOD bias here. I made it 1, meaning that the MIP is going to start at LOD 1, which is half the resolution. So between 2048 is going down to 1024 as the max size that it will display. And if I look right here, notice that I have a LOD bias of 1. So you notice that for this texture and this texture, the normal map, the diffuse for asphalt and road, I forced these textures to be 1K, even though the dimensions are 2K each. I force them to be max 1K. So look at all your textures. Make sure that you don't have excessive textures that are really big. Manage the size, and always make sure that they are a power of 2. All right. Those are very important when you're, again, adding all of your custom assets. And yeah, there you go. And again, I'm spending the time here. Probably a lot of you already know this, but this is important. If you're new to Unreal, if you're a beginner, if you're following my tutorial on how to add all of your custom assets, I'm seeing this come up a lot. Make sure you follow these steps and optimize your assets as much as possible. PCG's focus is actually on the road generation and spawning your assets in a logical way. It can use any asset, which means that it's on you, right, to optimize your assets as best as possible to make sure that your city runs well. Now, with that said, though, I am including a lot of different ways to improve performance with whatever asset you add there. So let's take a look at the second point here, which is max draw distance. And basically that is, we're going to look at it for roads, buildings, props, and foliage. And the idea here is that right now, even when I'm on game mode, if I go all the way up and I go out of game mode by pressing G, notice that there's a lot of buildings right there all the way. I'm looking at the entire city, which is why you're seeing this frame rate. I press G for game mode, and immediately you see that I am cutting some of the really far buildings. That's because I've set up these buildings to have a max draw distance. If you're farther than X, Unreal will automatically not even render the asset, which of course saves a lot in performance. And you can see that if you click on any of the buildings, right here, I actually have it under setup. Automatically, you have call distance. Max draw distance and call distance, by the way, are the same thing. And right now, by default, I have it at 80,000 units. 80,000 units is still pretty far. If I grab this and change it to 10,000 units, for example, and I start going back, notice that it immediately disappears because I changed it to 10,000 units as opposed to the default 80,000. So one way, I'm going to go back to 80,000 here. So one way you can improve performance is by reducing the max draw distance for your buildings. So right now, if you go into buildings, you click on select all buildings, it'll try to select all of the buildings, and right here, because of the subways, it's not going to present all of the options because the subways are a different class. But I'm gonna deselect the subways for a second. And right now I have all of the same buildings, which is my base class. You can come all the way down here and notice the call distance is 80,000. I'm gonna go ahead and place myself in the exact same view. I have a little key. It's about 48 to 50. If I cut the call distance by half and I make it 40,000, I just press enter. It's gonna take a little while because it's updating so many meshes. You're gonna see that the performance should increase from this exact same view, because now we're telling Unreal that there's a lot less buildings that it needs to render around the player's camera. Oh, and of course it has to autosave as I am trying to get this done. Give it 1 second here. Sorry about that, guys. While this saves, I do want to mention, if you don't see this little button here, don't worry. I literally just added this last night as I was going through and creating my level. I realized that it would be really nice if there was a way for me to select all the buildings automatically. So I added this little button. This is coming in the next update. So if you don't see this, you can still go manually here and select the meshes. If you do see it, that means that you have the latest update. So just wanted to mention that. All right. So now, if I click on play, you notice that a lot less buildings are being rendered in the background. There were a lot more that were rendered before. If I click on play now, give it a second here to play, we should see better performance. All right, so you see that we are now at over 90 frames per second, which we were 80%. So we got about 10 frames per second back. So again, you can go ahead and play with those numbers. I'm gonna go ahead and exit. But now notice that we're rendering a lot less buildings, and as we're moving, we're seeing more and more buildings. Notice too that these buildings here are a lot more dense than the ones here. So if I stand up right here and look here, I should get a lot better performance than if I'm looking this way, based on whatever I'm looking at. I'm gonna go back here. You can do the same thing for the props. So I can just select all of the fixed props here, for example. And in this case, if they are static meshes, you're not gonna get an option here. What you can do is go into the search and type max, and you'll see max draw distance, and by default I have 50, but again you could make them 20, for example, and then you can go ahead and deselect, and you can do the same thing for the random props or even the foliage. Notice I have a lot of foliage here, and notice that even though the buildings are called out, we have all of the foliage. You can do the exact same thing for the foliage. Select the foliage. Look at all these. They're all single static meshes. Go into the search bar. Click on max or type max draw distance. And in this case, we have several values. That's okay. How about we make them 20,000? And you can see how immediately, yes, we're going to continue the deselection. Immediately, a lot of that foliage disappears. So now if we look this way, we no longer see the foliage around there, which we used to see it. So the point here is, guys, that you need to manage the max draw distance to better play with performance as one of the ways in addition to preparing your assets. So based on the type of game that you have, right? If you're always on the ground, if you're not super fast moving, if your city is very dense, you can afford to have a low draw distance because people aren't going to see a lot behind the tall buildings. If your city is a lot more sparse, then you may want to increase that draw distance because, of course, you see in the background here, for example, you see how the buildings are popping up. That's not really good, right? So in this case, we probably want to increase that draw distance because this is pretty obvious that things are just popping into view. So you have to play around with those settings until you get basically something that makes sense for your use case. But that is one of the ways that you can do that. For the roads themselves, you can do the exact same thing. Right now, the roads are 40,000, and these are per segment of the road, not for the road itself. So again, you can select one single road and say, hey, for this road, instead of 40,000, I'm going to make it 10,000. And notice now that those segments are no longer rendered when you're there. Of course, I think 10,000 is too low, but one cool thing you can do is you can come to the roads and you can use this drop down to select all of the roads of a type, say select all main roads. Then you can come down here and say, hey, is it 40,000? How about we make this 30,000 instead? Doesn't have to be so dramatic, right? And we can do the same thing for the minor roads. Instead of 40, we can make this, I don't know, let's make it 20,000 for all of the minor roads. And then we can select all of the side rows and make this 20,000 again. So those are the things, and of course you can see that as soon as I start going up, things start to disappear much more quickly than they used to before because I am controlling that draw distance. Now, what causes my computer specifically to give me more frame rates or not depends obviously on my machine. So you're going to get different results as you're doing this based on your own specs. So just keep that in mind that in my case, for example, I have a 1070, 32 gigs of RAM, decent CPU. So a lot of these things may not look like they're doing that much, but if you have a lower spec machine, it could probably do a lot more for you. So play around with those values and you'll get different results. All right. The other thing you can do is adjust the interior blueprint trigger size. If you watch my video for the interiors, you know that right now every single building here has an interior blueprint with a pretty big trigger. So just as an example, I can grab this building right here, and if you go down here, you can see that I have a reference to the interior class. I click on the icon here, and I am now selecting the actual interior blueprint. And if I come all the way here and I show the trigger, and I remove the hidden, look at the size of this trigger. That means that as soon as I enter this trigger, the interiors of this building will spawn. And by default, I have the triggers fairly big. So if I select a bunch of these interiors, as I'm walking through the street, all of these meshes inside are spawning. That's a lot of draw calls. What you can do is you can reduce the size of this trigger, and you can have the trigger scale right here. So instead of 200 by 200, you could make this like 100 by 100. Still pretty big, but not as big. And if you make this change to all of the interiors in your city, you may have some pop-in, or at least for the buildings inside, it may make sense to have the trigger smaller because you can't really see the props inside. Compare that, for example, to the trigger for the gas station, which is this guy right here. You may want to keep it this wide because as soon as you enter this trigger, the cars will spawn. If you make this trigger too small, then there's going to be very noticeable pop-in. So you can't think about this as a one size fits all. If all of the interior props are, occluded by the walls, make the trigger very small, and that way you'll save a huge amount in performance. If it's something like this where it's open air and you can see it from really far, or like if you come here, for example, you want to see like the interior crates, you might want to leave that much bigger. And you can do the same thing for the prop trigger size. Even though this is going to be a lot less impactful, I'm still going to show it to you anyway. So if you look at the sedan, for example, here, let's just go to one of these guys here. My prop spawner right here, you can see that we have a car parked. If I actually select this guy, you'll notice that what we're actually showing here is an actual mesh, a static mesh, not a skeletal mesh. And the idea here is that you have a trigger, and when the player enters this trigger, and only then, I will replace the static mesh, which of course can be instanced by Unreal, with a skeletal mesh, which is not automatically instanced. And then once you go in and you enter the card, then you have the actual blueprint. So you can also adjust this trigger to be something smaller by using this activation and imposter trigger here to do the same thing that you would do for interiors, even though because this is a random prop, you're not going to get as much bang for the buck as if you did the interiors. But I still wanted to show it here. So yeah, those are the main things. One last thing is hierarchical LODs. I'm going to quickly mention this. I'm not going to spend too much time here. Guys, again, I'm giving you just high-level points. But the idea here is that in order for you to reduce your draw calls, even with all of these precautions, you still have thousands and thousands of meshes. One thing you can do is use the hierarchical LOD system to automatically combine meshes in clusters into single meshes. So, for example, if you grab this cluster of buildings here, you could say, hey, I want all of these buildings here to be combined by Unreal into one single mesh that will display it in the distance. Obviously, when you're getting close, Unreal will automatically populate the actual individual meshes, but when you're really, really far off, like in the distance here, you don't need all of those buildings in the horizon to be single meshes. You can combine all these into one or two or three or maybe even 10 meshes and significantly reduce the draw calls. And for you to do that, you need to come into the world settings, and you need to come to the LOD section here and click on Enable Hierarchical LOD System. And once you do that, if you go to the Windows panel here, you can click on Hierarchical LOD Outliner, and you can actually build and generate clusters based on a bunch of settings here. I'm not going to do that because it'll take a very, very long time. But you can leave Unreal to calculate the clusters, or what you can do is you can spawn, let's see, hierarchical LOD volumes into your scene and manually place them and tell them when you want those clusters to be. Now, of course, because I already figured that it's very, very tedious to drop all these volumes manually. What you can do is, you can use editor scripting to spawn them automatically. So if I go all the way up, it's going to go down here so you can see the entire city. If you click on the plus sign here, there is an HLOD tab, and you can see that I have X scale and Y scale, and I can automatically spawn those same volumes here throughout your city. So if I click on spawn volumes, you'll see that we automatically have spawned a bunch of hierarchical LOD volumes of scale 1000 by 1000 units, and they're exactly matching the city limits. And you can see that I have them all selected. And now if I go back and open my hierarchical LOD outliner and I try to build, the tool will automatically use these volumes as clusters. Now 1000 by 1000 is way too big in my opinion, but I just giving you as an example. You probably want the clusters to be way smaller, maybe 400 by 400, or maybe even less than that, 250 by 250, so it'll be a lot more. But the whole point is, if you want to use HLOD, I would recommend using that as the last step when you're completely finalized your city. It's going to take a while. Enable it in world settings. Use this handy tool so you don't have to manually place them. And then you go ahead and build. And that should give you a significant performance boost. Alright guys, I think we hit all of the points I wanted to cover in this video. There are indeed more things that you can do. You can use level streaming, for example, to actually load sections of the city, and you can manually manage your draw distance at runtime. And those are going to be covered in a separate video. I have 2 more videos coming related to performance, but this is just the baseline on how you need to prepare your own custom assets to optimize, and how you can manually change your draw distance to get that target performance that you want. In the next video, we'll be taking a look at a very handy blueprint that I created, which should be coming in the update, to automatically manage your max draw distance at runtime as the player moves around the city, basically going over some of the problems that we covered in this video. So hopefully this was useful to you guys. I'm trying to cover as much as possible based on the feedback and comments and questions that I'm getting. I hope this was useful. Again, this is a lot of general information, but it's probably good to have it all in one video. So if you have any questions about what I said today, or if you have any other tips for the community, please leave them in the comment below, or join our Discord server, come to the PCG channel and let us know what you think. All right, guys, thank you so much, and I'll talk to you in the next video.